So here we begin our exploration of inverse functions. Now, put very simply, the inverse of a function is a function that undoes the effects of another function. Now, before we can get into looking at the definition of the inverse of a function, we need to explore some of their features first, which brings us to inverse relationships. So to get us started, let's consider the set of ordered pairs containing the points 1, 2, 3, 4, and 5, 6. Now we of course know that the domain is the set of all the x values of these ordered pairs, and the range is the set of all y's. Now to produce the inverse of this set of ordered pairs, all that we need to do is simply interchange or switch the x and y coordinates. So by switching or interchanging the x and y coordinates of each ordered pair in our given set A, we produce the inverse of this set, denoted a to the negative 1. And notice these 3 new ordered pairs in the set. Now I want to pause for a cause real quick and think about this notation. This negative 1 is simply the inverse notation, not an exponent. So again, when we're working with inverse functions and inverse relations, we just want to be mindful that this negative 1 implies the inverse. It's simply notation, not an exponent. Now, to help us appreciate the relationship between these two sets, let's consider the domain of this inverse. So in thinking about the domain of the inverse set, we realize that, wait a minute, this domain 2, 4, and 6 is the same as the range as the given set. And we see a similar comparison here between the range of the inverse, 1, 3, 5. The range of the inverse is equal to the domain of the given set. So this is the first important observation that we're making about inverse relationships. Now, to help us see some more, let's consider plotting the ordered pairs for the given set as well as the ordered pairs for its inverse. So looking at the graph here of the ordered pairs in our given set A, compared to the ordered pairs in the inverse, we can see that these 2 points, the function and the inverse, are a perfect mirror image across the diagonal line, y equals x. So we're starting to build a rather large list of important features that relate functions and their inverses. So let's write down some of these observations. So the last observation that we want to make here in looking at comparing a given set to its inverse and this graphical notation is that each x value in the domain corresponds to one unique y value in its range. So another way of thinking about this is that each y value in the range corresponds to only one x value in that function's domain. Now what's really interesting is that all of these features here that simply apply to sets of ordered pairs are going to transition very naturally to functions. So let's explore that in more detail.